Hello students, my name is Vikas Agarwal and we are here to discuss KVPY paper of 2019 as Extreme Part 2 of Physics. We are currently discussing question number 95. Let's say what the question says. So there are 4 electrons, each of mass me, and they are confined to move in a one-dimensional box of size L. Assume that the electrons are non-interacting, they obey Pauli's exclusion principle, and they're described by standing de Broglie waves confined within the box. We've been given that alpha is equal to h square by 8m L square, and u naught is the ground state energy. So let's understand what we have to do in this question. So there is a region, one-dimensional region of length L, and electron is confined to stay within this region, described by standing wave of de Broglie standing de Broglie waves. So this means that if we consider electrons to be making standing waves within this box, which basically means that whatever is the wavelength, whatever is the de Broglie wavelength of the electron, those wavelengths should follow this rule that integer multiple of one loop length, which is lambda by 2, should match with L. Okay, so this is the basic condition that we have to use in this question or in such questions. So here we can replace lambda by h upon p, which basically means that we can write the momentum of electron as nh by 2l, which means we can write kinetic energy of the electron by using p square by 2m. It will become n square h square by 8ml square, which ultimately becomes n square alpha. Once you have formulated this relationship, now this question is very easy. Apart from formulating this expression, one additional important aspect of this question is to understand that the question says that the electrons follow Pauli's exclusion principle, which means that we have to consider 2 electrons in each energy level. So corresponding to n equal to 1, we will have 2 electrons, and corresponding to n equal to 2, we will have 2 electrons. So this means that the 4 electrons will occupy a maximum of 2 levels corresponding to n equal to 1 and corresponding to n equal to 2. With this in mind, let's read the options. A option says that the energy of the highest occupied state. Now, highest occupied state was the second state. So K2 would be equal to 4 times of alpha and not 16 alpha. So this is incorrect. U naught will represent the ground state energy. So that will correspond to n equal to 1. So it will equal to alpha. U naught will be equal to alpha and not 30 alpha. So this is also incorrect. Total energy of the first excited state. Now, first excited state will correspond to n equal to 2. So the energy corresponding to n equal to 2, we have already obtained it as 4 alpha, which can also be written as u naught plus 3 alpha. So u naught plus 9 alpha would be an incorrect expression. And now going by the same logic, if we check for option D, which says that the total energy of the second excited state. Now second excited state will correspond to n equal to 3. So K3 will become equal to 9 alpha, which can also be written as alpha plus 8 alpha, and this alpha is nothing but u naught. Right, so it becomes u naught plus 8 alpha. So we can see that this option is the correct one. So to this question, option D would be the correct answer, and that is indeed the correct answer. I hope you understood the solution, students. I hope you like the solutions. Thank you for watching and stay tuned for the next question.